Hello everyone and welcome back to another video. In this video we are going to start our unit on statistics and we're going to focus on measures of central tendency. So what is statistics? Statistics involves the collection, organization, summarization, presentation, and interpretation of data. We've got two branches of statistics that we could talk about: descriptive statistics and then inferential statistics. Descriptive statistics is the statistics that describes things. It's the collection of data, the organization, and then summarizing it and presenting it. So we start out with descriptive statistics, and then we can branch off and interpret things about the data, and that leads into inferential statistics. The first thing we're going to talk about is measures of central tendency. So these are things like the mean, the median, and the mode. And this book calls it the arithmetic mean. So the mean is really just the same thing that you think about when you think about the mean. A lot of people call it the average. It's the sum of all the data values divided by how many values you have. So, for example, let's say we were looking at test scores. Maybe we had a 79, a 98, an 83, and a 77. And we want to know what was the mean of our test score. Then we would add them all up. So 79 plus 98 plus 83 plus 77. And then we would divide by how many, in this case, tests we have. So we would divide by 4. When you do this by hand, you're going to want to add the numerator numbers together first. So I've got 337, and then we're going to divide that by 4. And I'm adding everything off screen on my calculator. So I got an average of 84.25. So that is the mean of those values. Now we can also find the mean using Desmos. So I'm going to go to desmos.com, and then we're going to find the mean of those numbers using Desmos. So I'm just going to click in the free box here. I'm going to type in mean and then parentheses, and I'm going to type all my numbers in. So 79, and I'm going to separate them with a comma. 98, 83, and 77. And you can see it's going to give me what that mean is. It knows to add all those numbers together and then divide by the total number of numbers that we had typed into our list. Now, when we start collecting data, we can collect it and think about it in two ways. We could think about it in terms of a population, which is the entire group that we're looking at studying, and we can think about a sample. So let's say we were looking at collecting the average voting age of Americans. The population would be all Americans who are eligible to vote, and we could collect information from every single person that's eligible to vote, but that would be really tedious. But that's what the population would do. So if we had that population mean, we could show that mean by using the Greek letter sigma, which is, the Greek letter mu. Population mean. Most of the time, it's not possible to collect information from the entire population. So then what we do is we take a sample, which would be a small subgroup of that population. And then we can run some statistics based on that sample data, and then maybe we could make inferences to the entire population. If we're talking about the sample mean, we're going to see this thing. It's called X bars, X with a bar over it. And that would be your sample mean. Let's look at another example. 6 friends in a biology class of 20 students received test grades of 92, 84, 65, 77, 88, and 90. We want to find the mean of those test scores. So we've got 6 out of that population of 20. So this is going to be a sample mean. And the way we would do this is we would add all the test scores. And then we would divide by how many test scores we had. So this is 495. And if I divide that by 6, I got 82.5. We could also do this in Desmos. We would say mean, parentheses, and then we would just list the test scores. Make sure you separate them with a comma. And you can see how it's given us our mean average, or mean there, which is our average. That's what most people think about when they think about average. The median is a number that's going to be in the middle. Now, we do have to put these numbers in order first. And then once we put them in order from, usually we think about smallest to largest, but you could do it largest to smallest also. We want the number that's in the middle. If we have an odd number of numbers, then it's literally going to be the one that's in the middle. If we have an even number of numbers, then what happens is we have 2 in the middle, and we have to find what's in the middle of those 2, which means we would find the mean of those. So let's go back to our example up here. We have 1, 2, 3, 4, 5, 6 numbers. Let's put them in order. So we have 65, and I'm going to mark them out as I do. We have a 76. We have an 84, and then an 88. And then we have 90, and then we have 92. So you can see how we have an even number of numbers, which means we actually have 2 that's in the middle. So the median is going to be what's in the middle of those. So it's going to be the average of those 2 numbers. And that's going to give us an 86. Let's look at a few more examples. We want to find the hourly wage for 13 business major interns shown below. We want to find the median of these. So we need to put these numbers in order from smallest to biggest. So we have 14.5, 15, 15.5, 16.75, 17.25, 17.5, 17.75. I see a 19.25. 20.5, 22.25, let me shrink this so I can get everything on one line. 22.5, 22.5, because I have 2 of those. And then 21.75. And it looks like I've used all of them. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13. So they're in order. Now we want to find the median. So if we have 13, that means we're going to have 6 in that lower half, and we're going to have 6 in that upper half. So that median is 17.75. Let's look at B. We have the number of hours of 12 commercial pilots that are flown in a 1 month period. They're asking us for the median again, so we need to put them in order. So this is where you may want to pause the video, try it, and then come back and check your answer. We have two 74s, 74, and then we have a 75 and a 78 and a 79 and an 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I am missing one. I'm missing that 72, so I'm just going to scoot this down and then write 72 right there. So they're in order. All right, so we want the number in the middle. So we're going to have 6 in the lower half and we're going to have 6 in the upper half. Since there's an even number of values, then that means we're going to actually have 2 that's in the middle. So I need to find what's in the middle of those. So the median would be 73 plus 74, and then we're going to divide that guy by 2, and it's going to end up being 73 and a half as our median there. Let's talk about the mode. The mode is the value that occurs most often. What's interesting with the mode is that we can use this on data that's numbers, and we can use it on data that's not numbers, so categories. So we can use it on what's called numerical data. And categorical data. So if we were to go back up here and we were to ask, what is the mode? The mode is the number that occurs most often, and it's very possible that you could have more than one mode. So we're looking for repeats here. So in this case, we do have a repeat of 74, and that is the only number that's repeated. So we would say that mode is 74. We could also take a survey of our class and we could ask favorite colors. And the color that most people liked would be considered the mode of that survey question. So you can see how you could use it for both. Let's look at another example. We want to find the mode of these two data sets. So we have 18, 15, 21, 16, 15, 14, 15, and 21. I think it helps if you put them in order. But you don't have to put them in order. It looks like we have 3 15s here, but we only have 2 21. So we do have some repeats, but 15 occurred most often. So that mode would be 15. If we look at the second example, let's see, we have 2, we have 4, we have 5, 7, 8, 9, 11, and 23. There are no repeats here. So we would say this does not have a mode, so there's no mode for that. Now we can find medians and modes in Desmos also, or at least I believe we can. So let's look at that first data set right here. I take that back. We cannot do modes, but we can do medians. I forgot to show that a minute ago. Let's say we want to find the median of the data set. And we'll look at this one since I put this one in order. So we have an even number of values. So the median would have to be the number in the middle, which means it would be the number between 7 and 8, which is 7 and a half. So we could type these numbers in Desmos. I forgot my comma right there. 2, 4, 5, 7, 8, 9, 11, and 23. You can see it's going to pull that median out. So we can do median and mode in Desmos. Let's talk about weighted mean. A weighted mean is something that you see in like courses when you talk about um, your class weights. Tests maybe are weighted a different way than the homework, which is weighted differently than maybe lab assignments or quiz assignments. You see it computed with GPAs also. Um, so, for instance, a science course is usually 4 contact hours, depending on which course you take, but a PE course is 1 contact hour. So there's a different weight to help you determine what the GPA would be based on your grade. So to compute a weighted mean, we're still looking at the sum, but now our sum is a little bit more complicated in the numerator. It's going to be a sum of each data value times its assigned weight, and then we're going to divide by the sum of all the weights. So let's look at a few examples. Let's say we want to find the weighted mean. So this student had a B in their English course that was 4 credits. In history, they had an A that was 3 credits. Chemistry, they made a D, and that was a 3 credit course at this example college. And then algebra was a 4 credit course, and they made a C. And we want to figure out what the weighted mean is. So at most colleges, A's are going to earn 4 GPA credits. B's are 3, C's are 2, D's are 1. And then if you make an F, it's a 0. So this B is going to earn 3 GPA credits. This A is going to earn 4. The D is going to earn 1, and the C is going to earn 2. So my weighted mean, I'm going to take 3 times 4. That's going to be the weight for that English class, plus 4 times 3, which is the weight for the history class, plus 1 times 3, which is the weight for the chemistry, and then 2 times 4, which would be the weight for the algebra course. And then we're going to divide by the sum of all the weights, which would be the sum of these. So there's my setup. So we're going to have 12 plus 12 plus 3 plus 8, which is 35 in the top. And then this student took a total of 14 credits. So 35 divided by 14, it gives us the GPA for that semester, which would be a 2.5. So let me see if I can put a page in here, and let's do one example. We'll add an example here. And talk about like a course grade. So let's say the syllabus says that homework is 15%, quizzes in this particular class, and I'm just making up a class. This is not necessarily what's going on this semester with our syllabus. Maybe they're 35%. Maybe you have some kind of project that's 20%. And then maybe test in some particular class is 30%. So let's say a student has a homework average of 85, quiz average of 93, project average of 74, and test average of 81. What is their current grade? And you could do this for any class that you have. So these are the weights. These are the current grades. So homework is 15%. So we're going to turn that into a decimal there. And right now they have an 85. Quizzes are 35%. And they have a 93. The project is 20%. And they have a 74. And tests are 30%. And their test average is 81. So there's my setup, and I'm going to divide by the total weights. These are the weights. So if I take 0.15 plus 0.35 plus 0.2 plus 0.3, there's my numerator. So when I add this up in the bottom, it's going to be 1 because this adds up to 100%. And then in the numerator, I'm 84. 84.4 divided by 1 would be an 84.4. So at this point in time, with those averages, based on their syllabus in this example, then the student would have an 84.4. So that's how we could use that to figure out our grade in any course at any given time. So if we have data that's not been manipulated or organized in any way, that would be considered the raw data. And then once we start organizing that and simplifying that, then it's no longer a raw data set. So the raw data set is the data set you collect in the beginning. We're going to talk about different ways to graph these data sets, and one way to do that is a frequency distribution. Distributions are nice because you can start seeing what the shape of the data looks like, whether it's skewed one way or another, and whether it is normal. And we'll talk about how to create frequency distributions a little bit later in this chapter.